Okay, time to get started. Welcome to this session, which is a session where we're going to discuss utility locating and the relevant technologies and techniques around utility locating. My name is Mike Langton. I'm your very friendly, very approachable Senior Applications Engineer at Guideline Geo. And at Guideline Geo, this is where we manufacture the Marla brand of GPRs. I've been around utility locating for over 30 years now. For the first half of that career, I spent that within a major manufacturer of EM locators. And then for the second half, I've worked with Guideline Geo with the Marla brand of GPRs. So I think I've got a broad spectrum, broad knowledge base for utility locating with those two technologies. And my first question that I'm going to ask or point out really is, why do we need to locate pipes and cables, buried pipes and cables that is? And I think top of the list, the most important part is to avoid or help prevent injury and potential death to workers. There are various reasons why that, which I'll highlight in a minute, but utilities can be quite dangerous if hit or struck by mechanical or hand tools. So the first thing there really is to help prevent that injury. Second part is to reduce public inconvenience. It can be quite disruptive, hitting a power cable or a telecoms cable, etc. And that can be quite disruptive to our lives. And this is where we really do depend on the utilities that are supplying factories, offices, homes, etc. And once those are disrupted, that can be quite an inconvenience to us. Also, to avoid additional and unnecessary costs. And if you think about this, if we were to knock out a shopping channel as an example, that revenue can be quite extensive. The loss of revenue can be quite extensive, and obviously claims can be put in place for those losses, etc. So it's quite additional necessary costs. And then there's also the repair of the actual utility itself, which can be put onto you or your insurance companies. Then leading on, there's the possible lawsuits and problems following that negligence and possibility of insurance excess threshold being raised or even cancelled in some parts really. And a mass loss of reputation. Obviously that cannot be a good thing. And some of these things can literally hit the news, the headlines, and that can be bad for the company that's excavating around the area. So looking at some of that potential damage that can be caused, here's a few examples. We have various different ones here. We've got an oil pipeline, gas pipeline, a water pipeline, all examples here. The bottom one in the right corner there is one that's been knocking around for a while now, but that's an image of a high pressure gas pipeline that was hit. And you can see the extent of the area. That object in the top of the image there is actually a farmhouse, some distance away from the point of impact. And this is an example. It's just a mock-up, is this, of someone actually hitting a power cable. Power cables can be very destructive. The amount of energy that's traveling down the power cable can be quite excessive, and that, or the potential that is. And when we hit a power cable similar to this, then we can have a mass explosion, and there's an effect happening within the cable. And you can see here, just across the top, there's these flashes. This is molten metal. That's the cable that's melted within this explosion, and that's all that energy is forced out towards the operator. Like I said, this is just a simulation, and that's just a dummy that's underneath there. So not to worry on that one. But it happens in real life, and the effects can be either in a way life-changing, but at worst could be potential death. And this is the actual utility that's been struck in that case, and we can see this is the actual tool from the pneumatic drill or the jackhammer, and you can actually see there is two sections that have been literally melted away. These are not bits of weak metal. They're quite strong, toughened metal, and you can see how it's gone across the cable there. And these two sections here is actually where you've shorted out two of the cores, and the short circuits happen there, and the current's built up, and in effect, massive arc welder in a way has melted down the cable, etc. And that's the explosion that can potentially come from even low voltage power cables. In a way, can be worse than high voltage. The high voltage tend to chip out quicker than the low voltage, but either way, I wouldn't want to hit either of them in effect. This is actually an image that's from the front page of some legislation based in the UK. This is the Health and Safety Guideline, HSG 47, and it's something to watch out for. There are certain countries around the world that actually has legislation in place, laws in place, enforceable laws that tries to prevent these injuries and damage through guidance and recommendations. So this is just one thing to watch out for. So some countries do have this legislation in place to create a safe system of work in a way. So when we look at utility locating itself, I think the first question here is what is involved in the utility survey, and there's various different factors. It's not just about using a locator. It's not just about using a GPR, etc. There are a number of factors when it comes to this. The first thing is a little bit of network knowledge. You do need to know the systems, the networks in place. For instance, this building in the background here, what's that building? It can be quite difficult to spot that from a distance, but you'll notice there's no windows there in the building. And if you walk up to the door, in this case, you will see that it will say something like danger of death, 33,000 volts. We know from that then that this is typically going to be a electrical substation. We'll have high voltage cables running into that, low voltage cables coming out. The high voltage will go in and come back out and run down to the next substation. So we need to have an understanding of what's going in there, what's coming out, just basic knowledge really. Because when we come to actually do the locating itself, we can't see the utilities. And I think the first point here is we need to be able to understand how the utilities work, how they connect, how they run down the street to be able to locate them. So a little bit of network knowledge is going to help you along the way. There's lots of other things you can see around this substation as well. And the next thing really is to try and get hold of any existing information. I'm talking about utility drawings or plans, and these are in place in various countries around the world. They are available. Sometimes they're not available, but where possible, these should be sought after really and tried to be found. This will give you information. Sometimes the information can be very good, sometimes not so good. Sometimes it's not complete, but it's all good information. It doesn't matter how much information, how accurate it is, it's all good information, because you as a utility surveyor, if you're going out to do utility mapping, locating, you are trying to pick up all the clues from the area, and both through plans and network knowledge and the other points that I'm going to bring up in a second. So it's just part of it. So we're going to use them as a reference to aid and help us locate the utilities. The next part is visual indications. You can see on the background photograph there are scars and trenches. I can just see some manholes, and also I've got the water valve photograph that just popped up there. These are all good surface indications that we have utilities, and maybe even what the utility is. For instance, like a water valve, that's a point of reference for us. So this is all good information. That's probably one of the first things that I do when I look out, when I arrive on site, is to visually have a check round, have a look for these visual signs. I'm talking about street lights, manholes, scars, trenches, etc. All these things. Next would be to deploy the electromagnetic pipe and cable locator. I'm going to talk a little bit more about that in a few minutes. But the first thing to do is to actually conduct the EM or EML, electromagnetic pipe and cable locator survey. So there we're going to try and locate all the services that it can load, particularly the metallic utilities, and we're going to connect and use different techniques to do that. But the first thing will be to do the electromagnetic pipe and cable locator and locate everything that's possibly locatable with that technology. Once we've gone through with the EM locator, then we're going to deploy the GPR. There's different ways that we can deploy the GPR again, which I will talk about in a short while. But the GPR is there to fill the gaps. It may locate some of the things that the EM found. It might find additional things. Sometimes both technologies will find the same thing. Sometimes one will find it and the other one won't. So it's all about building a robust methodology here. In a way, and using these different techniques and technologies all together to give you the most complete answer that is possible. I will say at this point that not all utilities are locatable. There are some for various different reasons that we cannot detect. But what I'm trying to say here is that if we use all these different techniques and technologies, you will maximize the chance of finding the locatable utilities out there. So once we've gone through with GPR, then we need to record those results. That recording could be just simply just hand sketches, measurements. We could be putting paint, markers, flags into the ground or onto the ground. We may use something like a GPS or a total station to accurately map those marks. It really depends on the level of survey or service that you're providing to your end client. So different levels in a way, different ways of recording that. And then I guess the final thing that could be done is to actually prove your results. And that could be by the use of a test hole, pothole, trial hole. This is where we do a small excavation in a safe method, in a safe way, to actually verify or in effect ground truth our results. And this is going to quantify your findings to the best ability or best way of actually doing that. Okay, so I think looking at that would be the base core of what's involved in utilities. There's always other things, utility surveying. There's always other things that you may add in or might do to that, but I think these are the basic steps in the utility survey itself. So let's take a look at the techniques and technologies now. Starting off with the existing information, then maps, drawings can contain an enormous quantity of information for the position of the buried pipes and cables, and they can be good. Obtaining whatever information is available should always be the first step to locating, if that's available. Some of the issues that with the drawings, maybe I've just touched on that slightly, they can be inaccurate or incomplete, and this should always be confirmed or completed by actually locating those utilities on site. But like I said earlier, this is all good information, and sometimes they're not so good, and sometimes they can be very complete and very accurate. But it's all about picking up those clues and information where possible. And the next part would be the visual indications. You can see here various different things. Yeah, I can see some street lights. Those will have electrical power, electrical cables feeding them. There is a CCTV pole, you just can't quite see the top of that. We have a telecom cover here, and there's a couple of sewer or surface or stormwater manhole covers here, and there's a fire hydrant cover there that's sticking up above the ground on there. There's various different things around there. So these are going to give you good indications to what might be there. So it's quite often the first thing that we're going to do. Like I said earlier, have a visual look around your site. And just a bit of a summary, looking at that photograph, I would probably come to that conclusion from this, where we've got these utility lines. That's what's potentially visible at this point. That could be swinging around this fire hydrant, so that's just a rough guess at this point. The fire hydrant could be running across the road. The actual water pipe feeding the fire hydrant could be going down the street. Hard to tell at this point. That's when we move on to the next techniques. But that's just a rough educated guess at this point to the position of those utilities. That gives you a good indication to start off with, like I said. So a whole number of things that's visible. There are going to be some things that are not visible, things like maybe like a gas pipeline, as an example, or a high voltage electrical power cable. Those aren't always visible or tend not to be visible. So there are going to be other things down there. I'm not just saying it's just those, and there will be other items that are down there as well. So technologies then, moving on to the technologies. I mentioned that the first thing to do would be the electromagnetic location, or EML or EM locator. This technology has really become the universal technology for locating and tracing buried utility lines. It has the ability to provide a wide variety of information from underground. It can trace and identify target lines quite easily, and we can measure the depth from the surface. Now, we do have to be cautious with the depth, both with EM and GPR. These, I would refer to these as an estimate, a depth estimation, rather than a depth measurement. There are ways of checking the values that the instruments are showing, but generally speaking, we would use the information just as an indication of the depth to the target line. So to be a little bit cautious with those. We can trace and identify sewers and other non-metallic services where there is access. Now, generally speaking, I'm going to just run through the theory in a second. The EM locators will generally only locate the metallic utilities, pipes and cables. Things like sewers, generally non-metallic, but we can actually lift a manhole cover and insert a small radio transmitter, often referred to as a sonde or a beacon, onto a rod, and we can push that down the sewer line, and that will transmit a signaling that can be received at the surface with the receiver. So there are ways of doing that, but there's quite a few utilities out there that it won't be able to locate, and we're talking about things like the plastic pipes, particularly, or even fibre optic cables. With the EM locators, they are relatively low cost. You could probably get a full setup sub $10,000 or 10,000 euros. So it's relatively low cost. It's quite portable. It's easily handled. The actual technique of locating can be quite complex, but the system and the actual receiver itself is relatively easy to operate. I would, as ever, with all these technologies, recommend proper training courses for this. It's not something that anybody can pick up and just walk outside and use. There is a skill and knowledge that's required to actually operate these systems. And generally they work in all soil conditions. Some of the shortcomings, I don't like to use the word problem, but it's just the way that the technology works. Some of the shortcomings in this technology cannot locate non-metallic lines such as plastic pipes or fibre optic cables. There are sometimes ways of doing that, but generally speaking, we can't locate the non-metallic lines. The utilities are taking some extent, some amount of trouble to actually lay tracer wires or tapes, and this can overcome that. But we have to rely that those tapes or wires are intact and are installed correctly for the EM to actually work properly and locate those. So we're actually going to locate the wire, not the actual pipe itself. And like I said, it's relatively easy to use, but they can be quite complex and lengthy, and particularly in a congested area. And like I say, it does take a little bit of skill and knowledge to operate them. But the basic theory here is that with the EM, we are going to take quite typically a signal generator, a transmitter, what's referred to as a transmitter. This is going to generate a signal, in effect sine wave. We apply these two connections here. We have a direct connection, a positive connection to the pipe itself, and then we make an earth connection. And in effect, what we're doing, we're creating a circuit here. So we're going to have current flowing from the positive connection down through the pipework, if it's metallic, obviously, back through the earth and back to the earth rod itself. And if we do create a circuit, then we will create a current flow. And that's what we're trying to do here. We're trying to create a current flow. So here the guy here is connecting, he's lifted the cover from a water valve. Now on this project here, we obtained the utility drawings and it indicated that the pipe was a metallic pipe, a cast iron pipe in this case. So that means we have some chance of tracing that. So he's lifted the cover there. He's going to take the positive lead, the red lead, connect it onto the valve or the fire hydrant or the fitting that's down there. He's going to put the earth out into the grass, typically out on the side here. Now the whole point here is he's trying to create a circuit. And when we create a circuit and we apply a voltage to that circuit, current will flow around that circuit. And when current is carried down a conductor, that conductor, whether it's a pipe or cable, that conductor will create a magnetic field, an electromagnetic field around the conductor. And it's that magnetic field that's being generated that's going to be detectable from the surface. But the key thing here, there has to be a circuit, there has to be current flowing for that magnetic field to be emitted from the subsurface. But the point is here, what we're trying to do here is we have in the receiver a coil, antenna or sets of antennas, different antennas, multiple antennas in there quite typically. But the point is here, we have an antenna, an aerial, and that is going to pick up that signal from underground. You can think of the Piper cable acting like a big antenna from a radio station. That signal's traveling out through the ground, and we have a radio receiver on the surface. And in the basic principle here, that is what the receiver is for the EM locator. It's a radio receiver, and it's going to pick up that signal that's been generated. And we get typically a peak response above the pipe or cable. There are some other techniques as well of different responses that we can get, and particularly we're going to use these for verification of the symmetrical shape of the signal, and that will then help us quantify the things like depth measurement and the position, etc. So we're going to use that technique or technology first. Like I say, mainly we're going to use that for locating the metallic utilities. So when it comes to the plastic, then that's where we're typically going to deploy the GPR. And GPR is a recognized technique now to work alongside the EM locators. Sometimes we can use one or the other, and I'm going to discuss this a little bit later, but quite often to do a complete thorough search of the area, we're going to use both GPR and EM locators. And GPR, generally speaking, will locate the metallics, but generally we're going to use it to locate the non-metallic. So we can use it to confirm what the EM's located, and hopefully then we can use it to complement the EM locator and pick out the things that it had problems locating. We can also locate other things with the GPR. We talk about things like maybe underground structures, voids. We can locate things like or pick out the different layers and that type of thing. So the GPR will assist you in other fields or other things that are buried in the subsurface. Could be things like underground storage tanks and that type of thing. So the GPR's ability to locate other things as well. But the basic principle behind the GPR, if we look at the antenna itself, this is just one of the antennas, side on. Inside the antenna, we have a transmitter and a receiving antenna, TX-RX. I've split them apart here just to show the principle. But we send a signal down to the transmitter antenna. It generates a pulse of energy in the form of a radio wave. So in effect, it's still an electromagnetic pulse, completely different frequency to the EM and the way that we're locating it, but it sends out this pulse of energy in the form of a radio wave or electromagnetic pulse of energy. That will start to propagate outwards. Here it's in a semicircular fashion because it's a shielded antenna, but it will start to propagate outwards into the ground. We do get some interaction between the transmitter and receiving antenna. That's the first response there that you can see on this section here. This is the recording on the receiver. This is what we refer to as the trace. So the signal then travels through the ground. We have a target here, and the principle behind the GPR is that where we get a change of electrical properties between two items, and that could be, let's say, the ground and a pipe or a cable, or in this case, maybe just a rock or a boulder. The change of electrical property here will cause a reflection, some or maybe all of the signal, depends on the material type itself. But it will affect some of the energy then back to the surface, where the receiver then will pick up that reflection from that object, and we get response on the trace. We convert that trace into a pictorial image, in this case a grayscale plot, but the peaks and troughs that you can see on this wiggle trace will create a lighter or darker grey. The grey is in the centre, white in this case is to the right, and black's to the left on this wiggle trace here. So we get this grayscale plot, and we take multiple measurements as we push the radar forward, and typically it would create a two-dimensional image at this point. We can move on to 3D a bit later, excuse me, but typically it's a 2D image that you see here. I'm not going to go through all the features that I'm seeing here on this image, or what we refer to as a radargram. That's for a different session. That's a theory session. Excuse me. But here we're just going to look at the image itself and just refer to it as the radargram. But I can see lots of responses within that radargram at this point. Okay. We can look at the different velocities for different soils, and when we know the velocity of the different soils, we can in effect calibrate the response, and we can then convert the measurements into depth. But again, like I said earlier, that is quite typically just an estimation of the actual depth itself. But this is more for the theory side, and like I said, this is a completely different session that we can have. Yeah, that's the basics of the GPR anyway, and the EM. So how do we bring them together then? Right, so here we've got a survey example of a street, just a residential area. We've got the guys here are undertaking a parallel sweep, and this is where one guy's walking down the road with a transmitter on the EML, and the other guy's on the other side with the receiver. And the idea here is that if there is a utility running across the road, as the guy on the left there walks over that utility, the transmitter will induce a signal into that utility, and then the guy on the right hand side will see a response, and he can stop at that point and mark the position. And this is one of the techniques within the EM, just one of the techniques. We don't do it all like this, but it's just almost a final check of the area once you've located all the utilities you possibly can via your connection techniques. Just to note here that the overhead lines here, we have low voltage overhead power lines, and those will be feeding. You can see the wires possibly going across the street. There's also telecom up there as well. There's some telecom cables that are feeding across to the properties. So it's always worth having a look above your head when you're in these areas to see what's up there, and just identify what's up in the air. So in this occasion here, the information that we got from the utility drawings and the visual indications, we knew that there was a telecom cable running down both sides of the street, one in each footpath, and we had a crossing between the two, so a connection. This quite often, you'll notice, in this case here, there will be a manhole on this side of the street, and there's also going to be a manhole cover on this side of the street, quite typically, not always, but quite typically. So if you stand on a manhole and you look across the street and you see one exactly opposite on the opposite side, you've got a good indication or a good chance that there is actually a crossing, a connection between those two manholes, and we could see that, and it was also visible on the drawing itself. We had a gas line running down the street, just in the actual roadway itself. We also had a water line running down there, and we also had a high voltage power line. This is all information that we gathered from the actual drawing itself. So those are the items that we could visually pick out. Sometimes on the drawings they will show connections to properties, but not always, typically not. But what we did here, we had a walk up and down the street and we looked at each property, and sometimes you may see things like valve covers. You might see the telecom cable rising out the ground if it's underground telecom cables. You might see the connections on the side of the property. You might look for gas meters on the side of the property as well. So all visual indications on the property itself. So we did that. We could see the telecom connections to the properties. We could see the gas connections and the water connections via the valves or meters, etc. So all that information there was gathered from just utility drawings and visual indications, and we could, in a way, approximate most of those positions. And the other information that we can get sometimes from the utility drawings, and this can be good information for utility surveying, is the pipe material, the sizes of the pipe, the telecom duct configuration, because often there's multiple ducts in there and we can see how they're actually laid in the ground, and also maybe the electrical voltages of the cables that are buried underground. Typically you might just note that as a high voltage or low voltage, but sometimes those might be actually indicated as 11,000, 33,000, etc. volts. So it gives indication what's down there, and that's good information, I think, maybe to hand on to the end client, to what is actually underground. So once we've gone through that and we've carried out the full utility survey with the EM locator, then we bring in the GPR, and just for your information here, GPR, and same with the EM actually, EM locators, we're going to go in two directions. We're going to scan across there in two directions to locate utilities. So the guy on the right hand side there is going to walk up and down the street, and he's in effect trying to locate the utilities running across the streets. So we're trying to run at right angles to the line. The guy on the left is going to go across the street to try and find the utilities running up and down the street. So again, like I say, trying to cut roughly at right angles with those utilities. Now these lines of data that we're going to collect are profile lines. The spacing between the two can vary. It depends on the congestion of the area. If I'm working in a downtown area in the city centre, then these profile lines are going to be quite close together, maybe within half a metre or less, or maybe a quarter of a metre. This is because of the congestion. We need to be able to map out lots of lines in that sort of situation. Here in a residential area, you may want to extend. You may not need to do half a metre profile spacing. Might do 2 or 5 metres because it's less congestion. There's not as many utilities. And in this instance here, most of the utilities are going to run relatively straight up and down that street. They're not going to cross over and lap over each other in a congested way. So we can do that. Don't forget, we need to locate down the footpaths as well, the sidewalks in both directions. So we're going to cut across the footpaths to look at, again, utilities running down the street, and then we're going to go up and down the best way we can to try and pick up those connections to the properties themselves. And you'll just take note there, the actual guy's looking down. There's a water meter just down there in the corner. So he's taking a note of that. And then if he gets a response on the radar, he can actually mark that position of that utility and then in effect track it across the street back to the main line. So with that in mind, there's a couple of different ways of actually undertaking utility surveys. The first one is a mark out. This is where we're going to physically locate in the field. In the case of GPR, we're going to interpret the data in the field, and we're going to put the marks down on the ground. With the EM locator, you're going to do the same thing again. You're going to locate, and as you're tracking or tracing the utility, you're going to put the spray paint down, or the markers or the flags, depending on how you're going to mark that. The advantage of this technique is it brings up all the technologies together and techniques. Don't forget, you've got your utility drawings, you've got the visualization, you've got your EM, and you've got your GPR You've got all these things around you to reference what you're locating, and that can be a very quick and effective way of mapping everything out. It can be completed just ahead of any excavation team, just a short period before that. And that in that way, it can be the most up-to-date information in terms of the results. A disadvantage to this is that there's no permanent recording of those utilities at this point. It's just the spray paint or the marker flags on the ground, and these over time can fade or disappear. In the case of flags, could be actually physically moved if somebody wants to, somebody wants to be really awkward and have a, yeah. I would say possibly what they think would be a bit of fun, but it's a serious matter here, so I wouldn't say it's fun in that way. So they can disappear, and sometimes if you look at the GPR, the information, some of the information within the radar gram could be missed if the operator's rushed or distracted, and in a way that could actually go for the EM as well. We can in effect potentially miss something. So that's the first way of in a way doing a utility survey, is to physically mark it out. And you could go on to actually record the results if you wanted with something like GPS, a surveyor GPS, or RTK GPS, or even a total station. So those could be recorded for long-term use, but quite typically we just put the marks down on the ground with a spray paint marker, chalk, etc. The other way of doing it is actually to map the utility, what we refer to mapping, and this is where we're going to definitely collect the information from the EM with GPS or total station. With the GPR, we would collect lines of data, and we would take those lines of data away for post-processing in the office. Advantages of this: we're taking a permanent record of the survey area and the data on that day of the survey. Different processes can be applied to the data, particularly with the GPR, which can indicate the presence of utility that might not be previously seen out in the field. So that could be an advantage. You may pick out things that you didn't notice whilst you're actually operating the system out in the field. Disadvantages to this technique is that some of the visual indications from the site that you have as you're walking around and looking around for these visual signs are lost. When you take that information away, you're losing that information. Unless somebody's gone out and previously taken lots of recordings of those visual indications. Adding the EM data to the GPR data can be a challenge, and it can lead to non-alignment of the information. Whilst you're out on site and marking out, you can look at the different technologies and you can assess the situation and think, okay, that's the same utility or not, as the case may be, and you can assess that quite easily out in the field. Once you take the two sets of data away, the misalignment can mislead you slightly, and to be on the cautious side, you would put down the results from both, but remember that could be coming from the same utility, as in because the two technologies are just slightly misaligning from each other. So that could be a slight disadvantage. When post-processing also, you need some additional training and understanding of data processing, and maybe leading on to things like CAD programs or GIS programs as well. So there's additional training and understanding of that. But like I say, it can be quite a good methodology. And in a way, you could actually do both techniques. You could physically mark out the area, and then you could actually collect the data and take it and post-process it. And that would be definitely the most robust way of mapping the utilities themselves. Now, one of the questions that I quite often get, can GPR alone by itself be classed as a utility survey? We have to be slightly cautious here, and quite often I may get a phone call for somebody asking for a GPR survey. The first question I would ask is, what are you trying to locate? And if they come back and say utilities, then I would say, well, you need a utility survey rather than a GPR survey. Subtly different, but occasionally, sometimes GPR can be used for just utility locating just itself, that is. The information can be limited. You'll find with GPR, one of the limitations for GPR is the actual ground conditions will limit the depth penetration and the effect to locate utilities. There are areas that the ground conditions are very good, very favourable for GPR, and other areas where it's not so favourable. So the amount of information that the GPR can give you can be limited in some places, but occasionally not. This is going to be an example I'm just going to bring up in a second, where we've deployed an array, and in this case we call it the mirror HDR. In this case, it's the array system that we manufacture, and the idea behind the array system, we're going to take lots of tightly spaced data channels, and we're going to stack that together to create a complete map of the actual area itself without any gaps in the data. But I would generally say that this technique cannot be relied upon for a safe system of work ahead of excavations. It's mainly in the planning stage of a project. And I've got an example here. This was just, like I said, just in the planning stage. The client was wanting to check the area for utilities, just to be able to provide information to the contractors for their tender process. So that gives them an indication of where things are. So this is an example in Jacksonville, in Florida. It was a route around the area. This is just a street view of that area. Just a short section here. We actually surveyed this area just on the side street. That's the main area down here that the project's going to be undertaken. Actually, what's happening here is that this overhead flyover is going to be brought down to road level, and we're going to widen this road. So that's the project here. So just ahead of any works or any tender for this work, we're going to go out and just use the GPR. So this was a bit of a trial. So we'd pick this side road here, and we collected the data just in half of this roadway, just to look at the performance and the response of the GPR data. We did deploy EM technology as well, to cross-reference and look at the amount of information that the GPR would be providing. Like I say, it was the array data. This is a plan view. This is just one slice of data at depth. I think this was around about just over ½ meter in depth. It's around about a couple of feet in depth. So this is a time slice, and these are actually the utilities running along and across the road as well. And there was one utility that was of interest, and it's this one running down here. It disappears, it reappears. That would be indicating either the ground conditions are affecting it, the signal, or it's changing depth. So what we did here is, and this is the advantage of array data, is that I can take a 2D line in any direction, and I picked this utility and I drew an arbitrary line along the line of the actual utility itself to create a cross section in the data. And this is the cross section. This line here, this planar reflector that rises towards the surface and then starts to drop again, is that utility, that line that I picked, the arbitrary line along. And this, in fact, from the records, indicated that it was a forced, or what sometimes is referred to as a rising main. It's a pumped main, a sewer. Because Florida is so flat, quite often they will pump the pressurize the pipe work, the actual sewer itself, to force the contents along the road. So here we could pick out that utility, and there's a step here where it's rising towards the surface and dropping back down again. But we can actually see some responses. I can see 3 utilities. There's faint responses in the data up here, which can be more clearly visible if I look up and down the actual data itself in the time slice. But we can see I've got 3 responses here, 2 responses here, and there's some responses further down the street as well. When we're collecting that data, we only collect it in one direction. The advantage of this type of array that we can locate the utilities in both directions in one go. and it's quick and effective, and we can collect the data just being, the system being towed behind a vehicle. So we compared this data against the EM data, and we found that we actually located everything that the EM did, plus some additional items as well. And we created this map at the end of the day. And we've got some things down here from the traffic lights. These are the sensors, and then we can see the utilities crossing and the utilities running down the actual street itself. So this really gives us a good indication the effectiveness of the GPR, and moving forward, it was recommended that GPR would be the way forward, just to that initial mapping out of the utilities and the position of the utilities itself. So a very quick and efficient way in this situation. That's just one very quick project that I wanted to highlight to you. Just to finish off then, just the last couple of slides here, just want to quickly talk about some of the utility standards that are out there. Various different countries around the world have utility mapping or subsurface utility engineering standards in place. Here's just a few examples. So if you're in and around some of these countries, it's worth having a look at the standards. These are in place to set the level of survey or the accuracy of the survey, or to quantify the survey to a certain standard. I'm not going to go through all of these right now, but just one example I've got from the UK. This is the PAS 128 from the UK, and we've got different categories of survey. Now this aids the people that are wanting the survey undertaken, and it can give you as the utility surveyor an idea of what they're asking for. So we've got 4 different types here. This is actually under review as we speak. We've got from type D through to type A. Type D would just be a desktop utilities record search. That's where we're going to gather information of the utilities just via paper or over the PC to actually look at what utilities could possibly be there. And we're not undertaking any type of utility survey with the techniques like EM or GPR. And then as we go through the different standards, we start to introduce the different things. It could be just GPR, it could be just EM, it could be both together. And then finally onto the highest level, which category A, and then we would deploy somebody to go out and actually do some trial holes, trenchings or vacuum excavations to actually verify the position of the utilities. So we've got different types of standards out there. Like I said, I'm not going to go through all this right now. We don't have the time right now to go through this, but it's worth having a look at what is in place if you're in some of those countries and around those areas, etc. Okay, so I just wanted to just quickly touch on those utility standards that are out there. Just worth having a search for those. So that's bringing me now towards the end of this session. Like I say, it's just a brief overview of the utility locating, particularly with GPR and EM technology, and what to expect from both of those techniques and technologies. So with that in mind, I would like to say thank you for attending. We will have a question time session now. I'll have a look through, see if anybody made any comments throughout the session. I'll open up now to questions when we'll have any discussions there. Before I do that, you can head towards our website, guidelinegeo.com, where you will find more information in and around utility locating and the products that we can provide and help you with those utility surveys. Or by all means, drop me a line, mike.langton@guidelinegeo.com. Drop me a line, ask your questions, or if you've got anything to discuss or you want to talk about, and like I said, just drop us a line. I'll be happy to respond to that at any time. So once again, thank you for attending, and I will now move over and see if we have any questions.